Okay, so this is lesson 3-4 practice, and this should be a pretty quick one because we are using the calculators to assist us in solving linear equations with matrices. So let's get right to it. Number 19, use a graphing calculator to find the inverse of matrix 2, 8, 5, 4. So let's go ahead and do that. So I'm going to use my graphing calculator and go into matrix, second matrix. And doesn't look like it's working. Let me clear out of this. Let's, I don't know, can I turn this thing off and on? Let's see if we can get in there. Okay, there we go. We're in. All right, so let's go over to this. This is an emulator, so that's why sometimes it works, sometimes it doesn't. So anyway, so I'm going to go ahead and enter this matrix. This is a 2 by 2. So let's go ahead and hit edit. And I'm going to say 2 by 2. And I'm going to overwrite whatever values are in there currently with these new ones. And that is 2, 8, 5, and 4. So 2, 8, 5, and 4. And yep, looks good. Okay, and so I'm going to go to second quit. And now I'm going to call that matrix. So I'll go to second matrix and just call A. I'm already on it, so hit enter. And I want to hit this x to the -1 to signify I'm going to take the inverse of A. Go ahead and hit enter. And you do get a bunch of decimals. If you want to get rid of those decimals, which we do, then we'll go to math and then go to fraction and hit enter. And there we go. We have our solution. So the solution would be -1/8, comma, let's see here. So let's do the inverse. Make that a little bit neater. The inverse of this is equal to, and what did I say? -1/8, 1/4, 5/32, and -1/16. And there we go. Okay, so for number 20 and 21, let's see, we are going to use our calculators to solve these. Okay, so let's go ahead and set up these matrices and, the matrix equation. So this, in this case, if I can get enough room here. So this is already in nice and organized with the x's, y's, and the numbers all together. So that would be 2, 4 for coefficients, -3 and 2, times x comma or xy, matrix xy, is equal to the 2 by 1 matrix 22, 7. Okay, let's go ahead and enter these into our calculator. So I'll go to, let me clear this out first actually. So I'll go to second matrix. And I'm going to edit this first one here. And again, it is just a 2 by 2, so that's good. And in this case, it is 2, 4, -3, 2. So 2, 4, -3, and 2. All right, and let's go to second matrix again. And we want to edit B. In this case, it's going to be a 2 by 1. And these values are going to be 22 and 7. Okay, and all we need to do here is go to second quit, and we need to say second matrix A, and we want the inverse of that, so to the -1, times matrix B. Like that, and hit enter, and we have our answer of 1, 5. So that means that x is equal to 1, y is equal to 5. All right, next up here, let's see, we have, put the matrix up here. Again, not a lot of room, but here I've got 1, 1, and 1, 2, 8, and 3, and 4, -6, and 7, times matrix x, y, z is equal to the matrix 11, 80, kind of looks looks like a 9, doesn't it? 11, 80, and then negative 62. All right, so let's go ahead and pop these into our calculator. So we'll go to second matrix, and we'll edit A, and this is now going to be a 3 by 3, and I believe the first one was 1, 1, 1. Then we had 2, 8, 3. Then we had 4, negative 6, 7. 4, negative 6, and 7. All right, let's go to second matrix, and we're going to edit B, and this is now going to be a 3 by 1, and in this case it's 11, 80, and negative 62. All right, so we will hit second quit, and I'm just going to clear this. That was our old thing there. I'm going to hit second entry. Because now these have new values, matrix A and matrix B have new values, hit enter, and there we go, we have our answer, 3, 10, negative 2. So x is equal to 3, y is equal to 10, and z is equal to negative 2. Yep, okay. Okay, and then finally, number 22, we have a real-world situation where we have euros and British pounds, and we're trying to figure out what they're both worth. So what we do know here is that Steve has 2 euros and 5 British pounds, and the total value is $9.10. Emily has 3 euros and 1 British pound with a total value of $5.55. We're going to write a system of equations to model this situation. So let's go ahead and we're just going to put a little arrow going down here. So the system, let's see, x is going to represent 1 euro and y will represent every 1 British pound. So in this case we have Steve, which has 2 times x, 2 euros, plus 4 British pounds, 4y, is equal to $9.10, 9.10. And let's see here, Emily has 3 euros plus 1 pound, not P, Y. And so that is totaling $5.55. All right, so we're going to write this system of equations as a matrix equation. So let's go ahead and do that. So in this case, it's just our coefficients of 2, 4, 3, and 1 times x and y, matrix xy, is equal to matrix 9.1 and 5.55. And let's go ahead and we'll solve for x and y. Okay, so we will clear out of here. Second matrix, we'll go to edit, and this is going to be a 2 by 2. In this case, we've got 2, 4, 3, 1. And we'll go to second matrix again and go to edit B. And this is going to be a 2 by 1. And this is 9.1 and 5.55. So 9.1 and 5.55. And we'll second quit. And we're to the main screen. We'll hit second entry. We have our new values in here. Inverse of A times B, and that is equal to 131 and 162. So x is 1.31 and y is 1.62. As far as interpretation goes, we would say that every let's write this down. So every euro, because we're trying to figure out how what they're worth in dollars here. Let's see here. Value, pound, and dollars. Interpret the solution. Yeah, so it looks like these are just going to be like American dollars. So anyway, so in this case, we would say that 1 euro is $1.31. I guess we'll say American. I guess we can't assume that they're American, but we'll say 131 American dollars. There are other countries that use dollars, so like Canadian dollars, for example. So I guess we're going to say American dollars. And then we would say, here we would say 1 pound. 1 pound is $1.60, whoops, not 61, 62 cents American. Pretty sloppy, but it's doing a lot of auto-correcting here. And I guess we'll just put the whole thing like that. Okay, and then 23 just says, your answers are going to vary here. Which solution method for solving systems of equations do you find easiest to use? Which method do you find the most difficult to use, and explain why? I would say probably the common answer here is going to be using matrix equations is probably the easiest, but it's probably the one that you don't understand as much because we did a lot of this through our calculator. Like, we didn't actually show you how to find the inverse of a matrix, and we kind of briefly went over matrix multiplication. So, and there's probably a lot of these properties for matrices are just, you just don't know them yet because you haven't been exposed to them. So anyway, but you'll probably say it's the easiest, but there's probably a lot going on behind the scenes that you're not aware of. As far as substitution and elimination goes, it's something, both of those you guys have had tons of practice with, so you are extremely familiar with them. And I guess you'd probably say you guys each probably favor one over the other. I would say for two systems of two equations, you guys probably favor probably substitution actually, and then three equations, three variables, you probably favor elimination. But for the most part, it's kind of like a combination of both because you guys are analyzing the problem and then just using whichever of those two fits the bill. So you can use either in all situations. It's just that's depending on how the equations are set up and what the coefficients are. One will probably be a little bit easier than the other. Anyway, that is it, and these are all of our, let me zoom out a little bit, so all of our solutions for lesson 3-4 practice.